You hear about incredible AI breakthroughs all the time, right? But here's the thing you don't hear. Most of those brilliant machine learning models, they never actually make it out of the lab. So why is that journey from a working model to a real-world product so incredibly hard? Let's get into it.
So this is the central mystery we're trying to solve. We have these brilliant data scientists, these incredibly powerful algorithms, and yet so many of these promising ML projects just get stuck. They work perfectly in a controlled environment, but then fail to deliver any actual value in the real world. So why does this keep happening? What is this gap between a prototype and a product?
And look, this isn't just a small problem. One survey found that a staggering 55% of companies that are using machine learning haven't successfully put a single model into production. I mean, that's more than half. It just goes to show there's this massive disconnect between building a model and actually making it work reliably out in the wild.
To solve this, we really need a better framework. So we're going to start by introducing what I call the 3 levels of ML. Then we'll break down each of the pipelines: data, model, and code. And finally, we'll see how automating all 3 is the real secret sauce.
So here's the core idea. I think the biggest mistake people make is thinking of ML software as just one single thing. It's not. The key is to see it as 3 interconnected but very distinct layers of engineering. A successful ML system is actually a combination of 3 totally different engineering disciplines. Think of it like this. Data engineering provides the fuel. ML engineering builds the powerful engine, and application engineering builds the actual car around it. If any one of them fails, the whole system just grinds to a halt.
This means that to succeed, you really have to master 3 distinct pipelines. First, you have the data pipeline, which is the absolute foundation. Second, the model pipeline, the core intelligence. And third, the code pipeline, which brings it all to life in an application. So let's start at the foundation with level 1.
Everything starts with data. This is level 1, the foundation of any ML system. And if your data pipeline is fragile, everything you build on top of it is going to be fragile too. This is where some of the sneakiest and most dangerous problems are hiding.
One of the biggest silent killers for models in production is this concept called data drift. Imagine you train a model on a perfect, clean snapshot of the world. The problem is, the real world is messy and it is always changing. When the live data flowing into your model no longer looks like the data it was trained on, its performance just slowly and quietly degrades.
And this happens everywhere in the real world. For a fraud detection model, criminals are constantly changing how they operate. In a factory, the physical sensors feeding a maintenance model can wear out and start to drift. For an e-commerce site, user preferences shift with every new viral trend. In each case, the world changes, and the model, well, unless it's retrained, it gets left behind.
Okay, moving up to level 2, we have the model pipeline itself. Now, this is what most people picture when they think of machine learning. Training and evaluating the model. But this stage is just filled with its own common traps that can completely derail a project.
Take this story from the team at Airbnb. They started with this super complex deep learning model, but they quickly found it was basically impossible to manage in a live environment. So what happened? They ended up simplifying it a lot, just to make it reliable. And the lesson here is so important. In production, simplicity and stability almost always beat raw complexity. Get a simple model working first.
The model pipeline isn't just about training. It's a whole multi-stage process. Evaluation is absolutely key, and not just for statistical accuracy, but against actual business goals. Then comes the really resource-heavy process of fine-tuning all its little parameters before you can finally package the model into a format that can actually be deployed and used by an application. And that brings us to our final level, the code pipeline. A model is pretty much useless until it's part of a live application that users can actually interact with. This is where ML meets traditional software engineering, and it has its own unique set of challenges.
So how do you safely release a new model into the wild? A common strategy is called shadow deployment. You run the new model in the background, sending it live traffic and logging its outputs, but your users only see the old model's results. It's basically a risk-free dress rehearsal. Another approach is blue-green deployment, where you switch all the traffic to a new green version while keeping the old blue version on standby for an instant rollback if anything goes wrong.
So we've seen the 3 levels: data, model, and code.
But managing them all manually is slow and just asking for errors. The real breakthrough comes from automating and connecting these three pipelines together. And this is the world of MLOps.
So, what exactly is MLOps? Honestly, the simplest way to think about it is DevOps, but supercharged for the unique challenges of machine learning. It's the engineering discipline focused on one thing: automating and managing the data, model, and code pipelines to get ML systems into the world reliably and efficiently.
Teams usually mature through a few levels of MLOps. Most start at level 0 with a slow, manual process where data scientists are basically just handing off models to engineers. The first step up is level 1, where you automate the model training pipeline. But the ultimate goal is level 2, a fully automated system where new data or new code can trigger the entire pipeline to test, validate, and deploy a new, reliable version of the application.
And this is what that end goal looks like in practice. Data flows in from a repository, and an automated pipeline just kicks off. It validates the data, it trains a new model, and it evaluates its performance. If the new model is an improvement, it's automatically registered and becomes ready for deployment. The entire process, from raw data to a production-ready model, is seamless, repeatable, and totally reliable. So when you put all of this together, the takeaway is crystal clear. Getting machine learning to work in the real world isn't about some kind of magic or waiting for a brilliant new algorithm. It's about applying mature engineering discipline to the entire system. It requires shifting our focus from just building individual models to building robust platforms that can manage all of them.
And that leaves us with a final thought. As incredible new models are developed every single day, maybe the real challenge and the biggest opportunity isn't just creating the next great model. Maybe it's creating the robust, scalable, and automated platforms needed to manage thousands of them in the real world. Thanks for watching The Explainer.